Okay, so we're supposed to do this last week. There was too many problems. I'm not sure what's happening on that screen, so you have to look this side or on the monitors there. Attendance code for you. I'm going to leave that up for the 5 minutes, and then I'm going to start going through the lecture. So usually I'll start with announcements while this thing is on, because I can't actually lecture while you're busy doing the attendance code. So as I said already, we have to do the attendance code. It's going to eat into our time. That's what the university wants. That's what I have to do. So attendance will be taken beginning of the lecture. As soon as I get set up, it will be on Blackboard as well. So those of you on Blackboard can also do the attendance code, even though you shouldn't really, because we need to calculate how many people are online versus how many people are in the actual venue. But that's not going to stop you from actually entering that code. Second thing is, there's a lot of people still trying to get registered, etc. If you have contacted me, I would have given you a way to access the lecture notes. Unfortunately, I cannot give you a way to access Blackboard, because Blackboard is controlled by the university, whereas Eve is controlled by the academy. So those are two different systems. So if you don't have access to Blackboard, you have to be registered to access Blackboard. There's no way around that. Then for the lectures are recorded. There is a way to access them. I can't show you right now, otherwise this code will go away. But you can access the previous recordings if you want to go over a lecture again. So that doesn't mean that you missed something in class, you don't have access to it. You can go onto the recorded lecture and view it again. There is an option to download as well. I'm not sure how reliable that option is. I haven't used it myself, but there is an option available if you want to download. Now, I would suggest if you're going to download or you do anything like that, do it on the UJ Wi-Fi. There is no limit on the UJ Wi-Fi, so you can download it and keep it onto your laptop or on a flash drive or whatever if you're in the general labs. Obviously, you as Group B, I'm assuming everyone here is in Group B, except for one gentleman who told me he's not. You should be all in Group B, and as such, I expect it to be. The only time I'll chase you out and say that you shouldn't be here is if the venue is 50% full. And as you can see, if you look behind you, it's not 50% full just yet. There's still another row, I think, of chairs that can take up people. So that's not to say it won't. There's still people registering every week. So last week, there's about 40 of you that registered. This week, I'm expecting another 20 or so. So the numbers to go up and down. We'll see as the week goes. Anyone still doing the attendance code? All right, so we're still waiting 2 minutes for you. So as far as your practicals are concerned, I did see most people did submit. There was about 40 people who did not. That is usually expected for the first practical, especially for people who registered late and could not upload in that time. Now, that being said, we do understand there's registration issues. You might be ill on a certain day, etc. So we do take that into account when calculating a practical component mark. If for those of you who don't remember, your practical component mark is the mark that takes into account all your practical assignments, your practical semester test, as well as your large practical at the end of semester called Practical X. So when we calculate your practical component mark, specifically your practical assignments, we do take into account that people do register late, that you do have issues, that you can miss 1 or 2 without issue. That being said, it's only 1 or 2. If you miss 5, then you run into problems. So make sure that you complete your practicals and that you do them well. Especially the first few. First few are easy. They're easy marks to actually get. There you'll also note there's also bonus sections in most of the practicals. Those are going to be on top of your normal marks, assuming that you get the normal practical correct. You can't get a bonus if your normal practical is incorrect. So once you get that bonus, it obviously contributes towards your practical component mark. You can't get more than 100% for your practical component mark, but you can get up to 100%, and it has happened in the past. Okay, so that time is going to time out. Well, not because it's going to go back to 5 minutes, but we're not going to care because it's Blackboard. You link, sorry. So, where did we leave off? We looked at elementary Java programming on Friday, or was it Thursday, in the last lecture, and we had a look at finishing up on Friday. Now what we're going to have a look at is some other basic concepts which you already know in C++, but we're going to try and do those concepts now inside of Java. So what we're going to have a look at is methods. We're going to have a look at how you work with arrays, and then we're going to have a brief look at sorting algorithms. Even though we're not going to go into detail with them, we're going to talk about them a little bit. Some of the concepts you've already done in the past, but we're just going to have a look over them again. So with methods, what you should remember from C++ is that with a method, you have something called the method signature. Now, with a method, there's a couple of components that you have to have a look at. First, you have to look at what are the modifiers. So the modifiers are basically augmenting either the visibility or the way we access that specific method. So you'll see in this case here, we have a method here called max. And with that method, it's public static visibility. It returns something called an int, takes 2 parameters, and also does something inside of the body. So those are different components. We have the modifiers, so public being a visibility modifier, static being an access modifier. We'll talk about static more in detail when we get to the object orientation lectures. Then we have the return type. The return type can be void, indicating that we don't return anything. Otherwise, it will be some sort of data type, either an object reference or a primitive data type. In this case here, we're working with max function that takes in 2 integers, returns an integer as an answer. The name of the function, that's very straightforward. It's the name. It follows the rules that we discussed in lecture 1. In lecture 1, we discussed identifier rules. Remember, it doesn't start with a number. It can be any length. It can only contain letters, digits, underscores, dollar signs, that type of thing. So that's what rules it has to follow. Now in this case here, it's a very simple function. There's nothing too complicated. It's just a max function trying to find the maximum between 2 values. How do I know it's 2 values? You can see the next part of our method is going to be a set of parameters. So we can have 0 or more parameters, and you can process it and work with it inside of the body of the function, and that's the last part, the body of the actual function. So all of those contribute towards the method signature. Well, specifically the method signature is just that first line, public static int max, and the parameters, that's your method signature, and the rest of it is the body of the method that goes along with it. So now with method invocation, how do we call a method? How do we invoke a method? So when we invoke a method, we pass in parameters, if needed, to that specific method, and then the method will do what it needs to do and return back a result. So if we have something that returns a result, we can store that result in a variable, or we can pass that on to another method, we can chain methods together, so on and so forth. If you have a situation where a method returns something, we can ignore that result. Maybe you don't care about it, maybe it does something in the background, maybe it modifies the state of an object. If that's the case, we can just call the method and ignore the result. Sometimes it might be the case that a specific method might return a failure state. If something is working, success, or it might return false. If it doesn't work, etc., we can't ignore it, but most of the time you shouldn't. If it returns a value, you should be using that value somewhere. And if it doesn't return anything, obviously it will return void, so then we just call the method, no issues with trying to deal with anything it returns. Order of parameters matter. Obviously they match whatever you specify in the parameter list. If you've got parameters A, B, C, you're going to pass parameters A, B, C in that order. Then the last 2 things that are very important on this slide dealing with method invocation is if you're working with primitive data types are passed by value. Primitive data types are passed by value. If you're working with anything else, which is a reference type meaning like pointers, object references, if you're dealing with those types, those are always passed by reference. So that means anything you change with that reference changes the original memory location. Whereas if you pass a parameter, we're using a primitive data type, any changes inside of the function doesn't propagate through to the calling function. Now we could sort of deal with the different ways of working with this inside of C++. You could have const parameters, indicating that you cannot change a parameter in the body of a function, or the method would be const, which would indicate that you cannot change the state of the object when you call this function. We don't have that in Java. There's no way to define those type of things. So we do have to take a little bit of care when we want to do it ourselves. There is ways we can do it, and that's something we'll talk about when we get to working with objects in object orientation. Next topic we're going to discuss is method overloading. So method overloading is a way of defining a method with the same name but different number or different type of parameters. So they have different things that they can take as parameters or maybe as returns, but they have the same name. So that's very important. The name is the only thing that indicates that it will be similar, but everything else can be different. So the two methods that are provided here, you'll see they are both max functions. I'm not sure what's happening on that screen. I can't fix it. Those of you who are struggling to see this side, you can always move over. There is a couple of spots there if you want to jump over that side. So there is two methods there, an integer max and a double max. So the integer max takes in two integers, and the double max takes in two doubles as parameters. If you look at the body of the function is exactly the same. The body of the function is exactly the same. You can see there it checks A or B. If A is greater than B, return A, otherwise return B. It's using the ternary operator, so the operator that takes in three parameters or three pieces of information. And it returns the result of whichever is the maximum between them. Now, what is important is when you're working with overloaded methods is that you understand which method should be called in certain situations. So on line 11 there, right to the bottom of the slide, you can see there is a function call, method call to max. It has a variable double D equals max of 5 and 3. So based on what you can see in this set of code, so you only have those two functions and then max, assuming this is written inside of a main or something like that. What is the method that would be called in this situation? Which method is called in this situation? Any guesses? The first one. Why do you say the first one? So we have one answer which says it could be the integer max because the parameters are type max. Anyone else? So in joining on to the first answer, if we want to call the method with doubles, don't we need to indicate that we have a double value, either with suffixes or in the case of doubles, because doubles don't need anything special, the .0 at the end can indicate double value as well. So I can tell you the answer, or I can show you the answer. I think showing you the answer is better because then you can see when you run the code what happens. So let's jump out from here. Obviously, we need this inside of here and in the wrong place. Let me just fix that. I do have to get rid of the line numbers because that's going to give us some problems. And as always, make sure that your code is neat. Okay, and this actually has to get put into our main method because that's the code we actually want to execute. And just so that we know what method is being called, we can just put system out print line. In both the functions so we can see what is the actual output for those. Okay, so I'm going to call my batch file. Remember, my batch file will compile my code, run my code, and then you can see the output, making sure that I do set the JDK path correctly. And if you look at the result there, you can see there's a whole bunch of other stuff in the way. Let's go and clean this up so it's easier to see what's going on. So I'm just going to do a clear screen here. Go back to my batch file. And what I want to do is just make this look a little bit better in terms of when we output stuff. Okay, so all I did there was put some messages out when I run my batch file. So I don't see all the commands being run. You can only see the things that's relevant to me. So setting the path, that's when we set all the path stuff. It outputs the Java C version there, so you can see that working correctly. Then it sets all my path variables, so setting the path to my bin, source, docs. Then it compiles, so it doesn't show me the actual command for compiling because I turn echo off, but it tells me that I'm at the point where I'm going to compile. Then it says I'm going to run, shows me the output of my run, which you can see there's int, and then I'm finished with my batch file. You'll see the similar structure in the batch file I'll give you eventually when you start working with an IDE. So you can see there it ran the integer one. So as correctly pointed out, because this max function only cares about what the parameters are, it will then look at what is the closest match. Since the max function in this case here has two integer parameters, the closest thing it can do is two integers as parameters, this max function that works with int. Doesn't matter what we're storing it in, because the function has to get called first before we assign the value to our variable. Now, if I change this, what would be called now? So if I change it from integers to doubles, what would be called now? The double method, double function. And you can see the output there is double, indicating that's going to be the double that gets printed out. What happens if I have one as a double and one as an integer? So what if my first parameter is double and my second parameter is an integer? What's going to happen now? It's going to run the double. Anyone else with a different answer? So again, we have to go according to what I said in the lecture last week. If I give you an option of A and B, and you don't choose A or B, that means you want to write the class test. Am I right? So who wants to write the class test? Okay, so who thinks integer is going to run? Who thinks double's going to run? Who thinks it's not going to work? Okay. And it looks like everyone else raised their hands, otherwise they really want to have a class test. So let's save this. Make sure that you do save. If you are using Notepad++, just to make sure that you are saving correctly. So let me just zoom in here, eventually when this magnifier wakes up. So if you do type something in your window and you see this little icon here changes to red, it means that your file has not been saved. So once you save, then you'll see it will change back to blue, which means your file has been saved. Anyone know what that little blue icon is? What's this icon? It's a save icon, no? What is the actual thing? The actual thing it's depicting, or the thing that depicts the save icon? It's a floppy disk. Something that you may have seen, or may have seen at your parents might have used, or your uncles, etc., that work in IT might have used that. I used to use that a very long time ago. When we had practicals and we had to get them marked, I had a stack of 10 floppy drives that I used to take every day to work, to school, university, or school as well. And if one of them crashed, there's your practical gone. You didn't do your work. So even though we don't use it every single day, it still takes a place in history as the save icon. A lot of people want to change it. A lot of people don't want to change it. But some interesting trivia for you. All right, so now you know when the little icon is red, the file is not saved. When it's blue, it has been saved. So run it again. And if you look at the output, it says compiled everything fine, and it runs double. Because of your type conversion, remember the numerical type conversion that we discussed in lecture 1. When we have something that needs to match a double, what happens? It gets converted to a double. So you'll have to specify the correct types going across. Now, if we do something funny like putting in a float value and putting a long value, then things can go wrong if the types don't actually match up. So you can see even though I changed the stuff, it still runs double because of the type conversions. Now, if I had more functions, if I overloaded it more and I had a method that takes a float, method that takes longs, etc., then it would be able to call the right things. But if I don't provide something it understands, if I provide a string and a double, string cannot be converted to a double very straightforward. Unless I convert it before the function call, the function won't know which one to actually use in that case. Okay, next topic we need to discuss is the scope of a variable. So the scope of a variable indicates where does the variable actually live? How long is it available in my code? Now, if we're talking about variables that are methods, the parameters, a parameter lives as long as it's inside that specific method. So that value t there lives in the body of the method. It can be used anywhere inside of that method. However, if we're working with a variable that's a local variable, so local variable means it's declared in the scope of something internal inside of a method, then it only exists when that scope opens and closes. So what do I mean by that? If we look at line 4, there is a for loop, and inside of that for loop, we're declaring a variable called I. And that variable, because it's declared in the for loop, we can only use it inside of that for loop. So as long as we're inside the body of the for loop, we can use it. As soon as we go out, you can see line number 8, we cannot use that variable any longer because it no longer exists as far as your compiler is concerned. Now, when we get to working with objects, when we work with classes, etc., we'll have another type of scope called class scope or instance scope. And we'll extend this concept of scope of a variable when we get there. Then the last point on the methods is talk about modular programming. Yes?
So next one was as well procrastinate to do.
Procrastinate. That's what students do best. So procrastination is just when you're supposed to do something and you do nothing. That's the concept of procrastination. Don't worry. I think everyone in the world is guilty of procrastination at one point in time or another. However, the way you manage procrastination, the way you manage doing work, that's a very, very important skill. A skill which is not very easily taught to you. Time management, very important skill to learn that no one teaches you. Don't ask me to teach you. I can't do time management either. So you have to manage your time that you have. Lectures, studying, all the different subjects, having fun, that should be on the schedule as well. But you have to manage it. You can't just do one all the time or do another all the time. Especially as you go on into your degree, there's less time for fun things and there's more time that you need to spend studying. Okay, so going on to modular programming. So when we work with any sort of big problem that we try and solve using programming to try and solve that specific problem, we don't go and write one giant method, one giant function to try and solve the whole thing in one go. You can, if you want a main method that's probably 1,000+ lines long. What we usually do is we break it up into pieces. You'll say, okay, I got this big task, break it into a couple of smaller tasks. Maybe some of the smaller tasks can be broken down even further into subtasks, and then you can solve the problem that way. The reason why we break down a program into a set of methods or a set of interacting objects when we get to object orientation is that it gives us a couple of advantages. So we have a situation where if someone else needs to read the code, or if we need to come back to it at a point later, if our program is broken down into a set of interacting methods or interacting objects, it's easier to read and understand what is going on. I can read a specific method and try and understand that method. If that method calls other methods, I can worry about that later. But I can understand one method at a time, and then eventually, over time, reading the code, I can understand those methods. If we have any errors, usually they're located within the methods or the methods that occur as method calls inside of that method. So I can sort of isolate any problems, any errors, and try and focus on only that set of methods to find where my issue is. Then the last sort of advantage that we're going to look at, there's more, but that's what we're going to look at for now, is that when we work with methods, I can avoid repeating code. So there's a concept that you should have learned in C++, something called dry. Anyone remember or heard of that term, dry? Don't repeat yourself, dry. When you write a method, such as that max function, do you want to write out that ternary operator every single time you want to write max function? No, you have a max function, you can do it. If you have a method that will, say for example, check if a user entered valid information, do you want to repeat that code every single time you ask for user information? No, you always pass it to the method can check for it, it can come back to your rest of your program. So you have methods as reusable units. If there's a problem with it, you just fix the problem in that method, it doesn't change the rest of the code. That's a very important concept, that we try and keep these methods separate. Any changes are separate from the other methods. When we get to design patterns, that's going to be a very important concept to understand. Now, when we're designing programs, there's two approaches we can take. And depending on what you're trying to do, where you are working, is it a new project, is it an old project, you might have to do one of these two. So there is top-down approach. And a top-down approach says, okay, we got this big problem. Let's try and break it down into a set of sub-problems that solve smaller tasks and work with it that way. Then you also have something called bottom-up. And bottom-up basically says, okay, we're trying to figure out the system. Let's make a set of methods work really well. We test them using something called test-driven development. And then as we progress further, we bundle classes or methods together, test those together, and we keep on doing that until we get a full system. Now, likely, you're not going to use only one or only the other. You might use a combination of the two. But usually, it will be a majority of one or the other. The way we're going to do things is going to be the top-down approach, because you have not learned test-driven development yet. It is a topic that is important. However, we cannot fit it into the curriculum of 2A, although I will be giving you additional things you can always go read and learn about it in your own time. So next up we're going to talk about is working with arrays. Arrays, fairly straightforward in the sense of working from C++ coming to Java, except for the fact that we're not working with pointers directly. So while Java, the Java virtual machine, works with pointers, you as a programmer do not have to actually go and work with pointers directly. So as with any proper programming language, we always start with index of 0. And we work with the arrays by specifying your square brackets. Your square brackets are basically an indication of working with an array type. So I want you to follow the convention of having type name square brackets, because then you're saying type name array. That's basically how you're going to read it. You can specify the array after your variable name, but sometimes it can be confusing depending on who's going to read your code. How do I access an array? Your variable name, square brackets, and an index there. Now, one thing that's going to be different from C++. In C++, when you try to access something that's outside of the bounds of an array, a couple of things can happen. Usually, if you access something that's either at the very beginning or the very end of your program, and it goes past the beginning, before the beginning, or after the end, you usually get a seg fault. Usually a little window pops up and says something's wrong, contact the developer, or contact something for help. That message seg fault indicates that you're accessing memory out of bounds. It could be the case the program still runs, just gave you incorrect information at the end. With Java, things are a bit more strict. If you access something that is outside bounds, either negative or something that is beyond the length of the array, you'll get something known as an array index bounds out of bounds exception. So it's an exception, something that happens out of the ordinary, and it will be thrown anytime that happens. So when you're writing code working with arrays and you see that array index out of bounds exception, note that you are accessing something out of the bounds of your array. So if your array is of length 5, so that means you have index 0, 1, 2, 3, 4, and you try and access element number 6, array out of bounds. If you try and access element -2 out of bounds, and then you've got an exception being thrown. Now, when that exception does happen, your Java virtual machine gives you the error and says, this is the length, this is what you passed. It's out of bounds. So you can figure out what's going on, why the error actually occurred. Other things we can work with that's also available in C++ as a different syntax, but very similar, is something called variable length parameter lists. You can have an argument to a parameter to a function that can be any length. So you can have a function call that takes in 1 parameter, a function call that takes in 10 parameters, a function call that takes in 100 parameters. As long as they're all the same type, you can work with it using variable length parameter lists. So with variable length parameter lists, you're basically getting an array of parameters. It always has to be the last parameter in the list if you want to use it. If you have more parameters, it always has to be the last one, or you can just have one by itself. So in the example on the slide, you can see there is a add method, and this add method takes in an array of doubles. Well, a variable length of doubles. So you can pass in any number of double values to this. If you pass in nothing, you can see there's code that will handle that. It will print on the error stream you didn't pass any parameters. Otherwise, what it will do, it will go through that array and add it to the total, and then return that total. We'll be using this variable length parameter lists. You can use it right now if you want to. When you define your main method, public static void main, and you pass your arguments for your function, so string array arguments. Instead of putting the square brackets, you can put triple dot. It will work perfectly fine. Then a couple of things we can sort of use that's built into the Java language, available in the package called Java Util, and we'll talk about packages very soon. So Java Util, Java belongs to the Java language. Util, utilities available there, and arrays, specifically looking at utilities for arrays. So with this arrays utility, we can sort. So there's an array sort. You can sort array at a specific point, start and end. You can do binary searches. Then there's also a way to copy or clone an array, and also a way to fill an array with a specific value. Not to say that you can't do these things manually, but that array utils are available to use as well. All right, so there's a few minutes left. I'm just going to cover this last few slides because there's not much code to look at here. It's just for noting all these different sorting algorithms. So with sorting algorithms, it's basically a way of defining an order of elements. So either you're going to say you have an array of something, let's say numbers, and you want to sort it. It's jumbled up. You want to sort 0, 1, 2, etc., or 9, 8, 7, etc., depending on which direction you want to sort. Now with sorting algorithms, they usually depend on the amount of things you want to sort, the number of elements. An array with 10 elements, it will take a lot shorter to sort than an array of 1,000,000 elements. Now we want to get the quickest short sort possible, but it also can depend on a number of other factors. How much memory do we take up when we're sorting? How stable is it? What I mean by stable is if we sort, for example, let's say that I'm sorting students by the student number, or let's say by surname, and 2 students have the same surname. It does happen. Which order do we sort them? If it's stable, the student that was first in the list will appear first, and the student that's second in the list will appear second. If it's unstable, the order can switch. So that's what stability means. So we're not going to look at the actual algorithms themselves. We can if you want to, but for now we're just going to look at the computational complexity, memory usage, and the stability. So selection sort, that's the easiest type of sort. Go through the array, pick out the smallest value. Go through the array, pick out the next smallest value. Now the problem with that is, if we look at the computational complexity, you remember big O notation? Yes? No? So big O notation is n squared. So however many elements you have, squared. So if you have 1,000,000 elements, that's going to take a really long time, because 1,000,000 squared is a very big number. However, with memory, it uses the memory in place, so it doesn't have to create extra memory for it to work with. If we look at something like bubble sort, best case, I think I swapped those around. The best case should be O of n, and the worst case should be O n squared. Also in place. Insertion sort, again, can be a bit better, but also has its issues. Interesting thing comes into play when we work with merge sort. If you look at merge sort, we have n of n as being the best case or the worst case, but it uses O of n more memory. So if you have 1,000,000 elements, we need to get another 1,000,000 elements of memory available to do something like merge sort. And also note there, it works under a recursive method as opposed to an iterative method. And then quick sort, even though there is many other types of sorts, the last one we're going to have a look at. This one does operate the fastest. However, you can write it in a way that doesn't use extra memory. It's also recursive, but it's an unstable sort. So there is more things I actually want to show you with this, but we are going to run out of time. So I'm going to end the lecture there. If you have any questions, I'll be here in the front. Otherwise, I'll see you tomorrow for the practical lecture. Just give me a minute.